So today we will be discussing about the p orbital, the shape of p orbital. So in my previous video I discussed about the shape of s orbital and we discussed about the radial nodes and the angular nodes, right? So now we will discuss about p orbital, the actual shape of orbital. So before going ahead, we must know that we will first find the orientations of p orbital. So the orientations of p orbital. Yes. So we know that here we are not considering any shell, right? So here we know that s is equal to 0, p is equal to 1 and d is equal to 2, f is equal to 3, right? These are the azimuthal quantum number. So the p is 1. So m, what will be the magnetic quantum number or the orbital orientation numbers of m will be -1, 0, plus 1, right? So it means there will be 3 orientations of p orbital. There will be 3 axes which will be termed as px, py and pz. So now we will look at the shapes of these orbitals px, py and pz. Okay, now let's look at the shape of px first. This is the axis, right? Let's first make this. This is px. This is actually dumbbell shaped. Px is dumbbell shaped. You can see over here. So the shape of p orbital is dumbbell, and this is the shape of px, right? This is y-axis, this y-axis, this is x-axis, this is x-axis. So this is the shape of px orbital. Now let's look at this is axis, this is x-axis, this is y-axis, x, y, right? Let's make this color. So this, you can see this dumbbell, it is on which axis? It is on x-axis. This is known as py. Okay, this is px, this is py. Now let us discuss this another axis, right? Okay, obviously I can't make a three-dimensional figure over here, so I am considering this is x and this is as z. This axis is z, because I can't create a three-dimensional figure over here, so I'm considering this as x. Right? So let's make pz. So this is pz. This is known as pz. As you can see over here, this is px because it is lying on the x-axis and it has dumbbell shaped. This is py as it is lying on the y-axis and it is also having dumbbell shape. Like all the all the orbitals of p subshell are having dumbbell shape, right? And this is pz. So now let's discuss one important thing, that the px, py and pz, they are degenerate. Now what does this mean? Degenerate. These are known as degenerate orbitals. Now what does that mean? Degenerate means which is having same energy, like they all are lying on the same subshell, which is P, right? P is the subshell, or you can say azimuthal quantum number. It is azimuthal quantum number, right, which is 1 for P, right? So here these three are degenerate, which means it is having equal amount of energy. These three are having equal amount of energy is equal in all these three orbitals, px, py, pz. That's why they are known as degenerate orbitals. Now there is one more thing to discuss. We have talked s orbital, that s orbital is a non-directional, right? It is moving in all directions, x-axis and y-axis and z-axis. But in this is directional. The orbitals of P are directional. Let us discuss how these are directional now. As you can see over here, px, right? Obviously it is moving in one direction only, which is px, so it means it is directional, right? When you're looking about and py, it is also moving in one direction, which is y, so it means it is directional. When you're looking at pz, obviously I can't draw a three-dimensional figure over here, but I have considered y-axis as z-axis is x and this is z, so it is moving in one direction. So this, like the p orbitals, px, py and pz, all are directional orbitals. I hope you understood the concept of dumbbell, directional, and the shape of p orbitals.